Right, in this video we're looking at algebraic fractions. We're going to look at simplifying, multiplying and dividing, and then adding and subtracting. We'll start with simplifying. So in order to simplify question 1, what you need to recognise is the b to the power of 1 divided by b to the power of 2. And I'll do that over here. B to the power of 1 divided by b to the power of 2. If we have the same base number, we subtract the indices. So that would give us 1 minus 2, which is minus 1, would give us b to the power of minus 1. If you go back to your index rules, you will know that b to the power of minus 1 is also the same as saying 1 over b. So coming back to this question, another way of looking at it would be this. ab over b multiplied by b. Those b's cancel. You're now left with just a over b. Dealing with it using the index form, ab over b squared. B to the 1 divided by b to the 2 becomes 1 over b, and a multiplied by 1 over b is just a over b. So you get the same answer. Looking at the second question here, I would start with the values first. 5 over 10 is 1 over 2. Remember, if we're not showing a power, it just means to the power of 1. So both of these are to the power of 1. Again, if you're dividing, your index rule says you subtract the powers if the base numbers are the same. So 2 minus 1 is 1, so we've now got a on its own, so a, and then b3 divided by b to the 1 comes b squared. So this is a combination now of straightforward division and knowing your index laws. Looking at this next question here, you can't really do anything with this question at the moment. In order to simplify this, make it look neater in other words, we would need to factorise the denominator. So we leave the numerator as it is. X is in both terms, so x comes out the bracket. Now if you look at this, you have got x to the power of 1 here, and you've got x to the power of 2 there. So again, x squared divided by x1 is just x. So I've now got 5x over y plus z. And that's it. Simplifying this last one here, hopefully you'll notice that this can be factorised, as can this. So now we have got 9 bracket x plus y, and we have got 3 bracket x squared minus y squared. 9 divided by 3 is 3. We've got x plus y here, divided by x squared minus y squared. Now we need to notice something here. This is the difference of two squares. So going back to your factorising and finding the difference of two squares, that would become x minus y multiplied by x plus y. And now we can cancel the x plus y's, because anything divided by itself is 1, and we end up with 3 over x minus y. Looks a little neater than what we started with. Moving on to multiplication. So in this case, the key thing to recognise is that this actually is the same as saying this. The numerator is multiplied, all divided by the denominator is multiplied. If I treat it in this way, that becomes 5 times 3, which is 15, x times x, which is x squared, y times y, which is y squared, so that becomes x squared, y squared. Now we can cancel the x squareds because anything divided by itself is 1. So we're left with 15 over y squared. Looking at the second question, so what I would do first is I would put brackets around these, and I would then factorise them before I multiply them together. So factorising the first part, a comes out the bracket, factorising its denominator, that one there you must recognise is the difference of two squares. 2 comes out the bracket. Now the reason why I would factorise first is we might get things like this that just cancel. That makes things a little bit neater. So if I look at this now, I can see straight away they cancel. Now what I can do is recognise that actually that is the same, so nothing changes here. And I notice a plus b is here and a plus b is here, so they can cancel as well. And I'm left with a multiplied by 2 over 5a squared, which is just 2a over 5a squared. Obviously a to the 1 divided by a to the 2, that ends up being 2 over 5a. And that's done. Let's take on a more complicated multiplication. And when I say more complicated, all I mean by that is just a bit more work. So the first thing we do now is factorise these, and then we'll start looking for cancellations, and then we'll start to simplify. So if I deal with the numerator of this first part, so I've rewritten that numerator over here. What we've got to do here is factorise by grouping. That was in another video. So here we go. 2 multiplied by minus 3 is minus 6. We need to find the factors of minus 6 that give us minus 5. Well, 1 times 6 gives us 6. If I place that as a minus and that as a positive, that gives us minus 6. And if you add them together, gives us minus 5. So this now becomes 2x squared plus 1x minus 6x minus 3. Let's factorise this by grouping. So we've got x comes out the bracket, 2x plus 1 in the bracket. I want to have 2x plus 1 in the same bracket. I want those to be the same. So I'm multiplying 2 by minus 3 to make it minus 6. And minus 3 times 1 is minus 3, so that works. Let's bring this together. We've now got x minus 3, 2x plus 1. That's factorised, so I can replace that numerator with that. Okay, let's do the same with the denominator. Here goes, multiplying a and c, we get a positive 4, finding the factors of 4 that when we add them gives you 5. Well, that's got to be a 1 and 4, both are positive. So here we go, we have 2x squared plus 1x plus 4x plus 2. Let's factorise by grouping. We now have x multiplied by 2x plus 1, and we have plus 2 multiplied by 2x plus 1 to give us the second part. Let's bring this together. And all we do now is write that underneath. Hopefully now you're seeing the purpose of this. The purpose is to actually cancel. So we'll come back to that in a moment, but hopefully you can see the purpose of this. Now, if we look at this part here, you need to recognise that that is x squared minus 2 squared, which is a difference of 2 squares. So that becomes x minus 2 multiplied by x plus 2. Same with this one, you need to recognise that is x squared minus 3 squared, difference 2 squares again. So it's x minus 3, x plus 3. Now we start to cancel. Let's show the whole lot over one division line, remembering that they're all multiplied and going across. So now we can cancel. X minus 3 cancels with x minus 3. 2x plus 1 cancels with 2x plus 1. X minus 2 we haven't got. X plus 2 cancels with x plus 2. So this simplifies to x minus 2 divided by x plus 3. And that's multiplying with fractions. So the key thing here, when dealing with these algebraic fractions, is you're looking for things that you can cancel. So moving on, let's look at division. We only need to do one here because the only difference here between multiplying and dividing is what you do to the second fraction. So you're going to change the divide to a multiply, and you are going to flip that second fraction. This is basic fraction rules when dividing. So a quick example, if I did 2 over 5 divided by 1 over 3, what that actually becomes is 2 over 5 multiplied by 3 over 1, and therefore I would get 6 over 5, and I could simplify that further. Okay, so back to your basic fraction rules. Let's get rid of that. So the first thing I would do here is on the left hand side, I would factorise both of these before I move forward. So 5 can come outside the bracket. I need to find the factors of minus 10 that add to give me 3. So 2 and 5, and it'd be a positive 5 and a negative 2. So that will become a minus 2, a plus 5. And if you're not sure, you could expand that to check it. Again, this is basic factorisation. Like I said, we are going to change the sign to multiply. Now, I'm going to deal with the denominator here because it becomes our numerator. That stays as a plus 5. Factorising this, factors of 4, that when I add, I get 4. Obviously, that's 2 and 2. So that becomes a plus 2 and another a plus 2. Right, what I would do here now is I would put that in brackets just to make it easier to identify what I'm cancelling. So there we go. So the 5, we have no other 5s. A plus 2, there's an a plus 2, so they cancel. A plus 5, there's an a plus 5, so they cancel. Looks like there's nothing else. So that becomes 5 over a minus 2, a plus 2. Now in this case, we could take that a step further because I know that one is the difference of 2 squares. I could just put 5 divided by a squared minus 4. Okay, let's move on to the last part, adding and subtracting. When adding and subtracting, the key thing is to make the denominators common. To make the denominators common, we need to multiply this fraction by x plus 2 over x plus 2, and we need to multiply this fraction by x plus 1 over x plus 1. So I'll write those in. Okay, so now we've got a common denominator. So I can show that. Now I've written that, I can expand these brackets. I've got 5x plus 10 plus 4x plus 4. I can collect like terms. So I end up with 9x plus 14, and that is over x plus 1 multiplied by x plus 2. And that's done. Same with this one, we multiply the first fraction by a plus 3 over a plus 3 and the second fraction by a minus 1 over a minus 1. Just going to extend these. Don't forget to put that part in brackets. Again, we now have a common denominator. We can expand the numerators. Remember, this is a negative here, it's minus. So we're doing minus 2 multiplied by a, which is minus 2a, and we're doing minus 2 multiplied by minus 1, which is a positive 2. That does seem to catch people out. Collect like terms, and we end up with 3a plus 17 over a minus 1 multiplied by a plus 3. Looking at the last one, the first thing I would do here is factorise both of these. So if I look at the first one, that becomes the factors of 10 that add to give me 7 are 2 and 5. So that's plus 2, a plus 5. This one is the difference of 2 squares, so that becomes a minus 2, a plus 2. So let's rewrite this, and we'll get rid of these. So now, rather than just multiplying this whole fraction by all of this denominator to get a common denominator, we need to recognise that actually there's already something common in there. we've already got a plus 2 in both of them. So we don't need to multiply this side by a plus 2. And we certainly don't need to multiply this side by a plus 2. So all we're going to do this time is we're going to multiply this side by a minus 2 and then the other side by a plus 5. Let's just move these across a little bit. So I'll show you that now. We're now multiplying this side by a minus 2 and again a minus 2 and this side by a plus 5. Right, we now have a common denominator and we can show that. What I would do now is expand these and write them as a numerator. So we've got 8a minus 16. Remember, that is a minus 5 multiplied by a, so that's a minus 5a. And it's a minus 5 multiplied by 5, which is minus 25. Now we collect like terms and we show it over the denominator. And that's it, done. Like I said, it's no more difficult than adding and subtracting and multiplying and dividing normal fractions. It's just a bit more work. Clearly, you need to know how to factorize. You need to recognize the difference of two squares. You need to be able to factorize by grouping. All of these skills will make dealing with algebraic fractions very straightforward. If you can do this, that's fantastic. Really well done. And again, as always, if you've got something out of this, please like and subscribe.